Okay, we're live. It's October the 19th today. We have a guest, Zoltán. What's your last name?
It's Lehóczky. Super simple.
Wow, that's very hard to pronounce for us Dutchies. Well, it's 19th of October today. We have a guest. The other presenters are Fanie, Reynders and Maarten van Stam. Maarten Meijer is a bit late and he's stuck in traffic, I guess, so maybe he joins in later. But let's start the show.
Good evening.
Hello, everyone.
Zoltán Lehóczky.
Muted.
That's right. Good evening, everyone.
So, where are you from?
I'm from Hungary, so not that far away. I actually visited Amsterdam once as well. So,
Once, and was it long ago or short ago?
yeah, about 3 years ago.
Oh,
So I will probably visit soon again as well.
Yeah. Oh, but maybe we can invite you for one of the SDN events, maybe. To do you do talks also?
That's a great idea.
Actually, I do. Now with Hastlayer, but I will also talk about a bit later. I'm also doing a bit of a roadshow, but just a virtual one, like events like this. But I also do in-person talks a lot, not just about Hastlayer, but also related to the open source content management system called Orchard, what we also work with a lot.
Yeah, it's a familiar name, I think.
Orchard, yeah, CMS.
Yeah,
well,
have you heard of Orchard?
Yeah, I have. I don't think I used it before, but I know the name at least. So.
Well, Orchard has been started by Microsoft a few years ago. Well, not just a few anymore, I think. And in a nutshell, it's an ASP.NET MVC CMS. It's open source. It's still supported by Microsoft, but it's community driven. And I think it's quite good.
What I tend to remember is that Microsoft started at first with the ASP.NET website, I think. And a bit later that the Orchard came after that to replace it somehow, I think.
Probably what you are talking about is the ASP.NET, the weblogs.asp.net.
Yeah.
Yeah, that actually runs on Orchard indeed. Like 2-3 years ago, I think it was migrated to Orchard. But there are a few other Microsoft sites that run on Orchard too. The only two I can recall are the Halo websites for the video game.
Okay.
Although they just use Orchard in the background. And so, one of the SharePoint marketing sites, can't recall the name.
Well, that's interesting because you would expect that to be a SharePoint site or something like that.
It's pretty funny, but the site promoting SharePoint, or I think the developer level stuff of SharePoint, is running actually on Orchard.
But Orchard is not .NET Core based. It's still the old .NET framework, ASP.NET, right?
Well, the answer is yes or no, or yes and no. And the reason is because the current production version of Orchard is running on standard ASP.NET MVC. But the next evolutional step of Orchard will be Orchard Core, which is actually running on the ASP.NET Core MVC.
I see. Okay. Because I know there's some interns of the ASP.NET or some interns at Microsoft that's busy building a blogging engine / but it's a very simple thing. So I was actually quite wondering if that's going to become a kind of an Orchard for ASP.NET Core. But you have Orchard Core, which is coming, which is great.
Is it this one?
So
yes,
that's right.
Yeah. So it's,
you have the hosted version and you have the the local version, right? That you can actually like Sitecore or like Umbraco. You can actually download it, unzip it, and run it locally.
Yes, indeed. So it's fully open source. It's on GitHub. It's an ASP.NET project. So you have a Visual Studio solution with C# projects and everything as usual. So you can download it and deploy and operate it just as any ASP.NET application. What you have under that Try Orchard button is something called .nest. This is actually our service. We have created it at Lombic Technologies, and it's the kind of the hosted version of Orchard. Okay. So it's a software as a service.
This is the one in the cloud, so you have a fully prepared environment there, so people can try it. Is that the idea?
Yes, that's right. It's a multi-tenant version, so there is no new application deployed in the ASP.NET sense for you if you create a new site, but rather you kind of get your own slot in that Orchard application, which is completely independent in terms of content of all the other ones. But it can be very easily created, very, very quickly created, very quickly deleted as well. And quite flexible still.
Interesting.
So how would you compare this to, for instance, .NET Nuke or something like that? Is it comparable?
It is, although I'm really not prepared to compare it because I really have very limited knowledge of pretty much any other .NET CMSs out there. Because in the last few years, I've been very focused on Orchard, only taking a look at the other CMSs to get some inspiration sometimes. But I have no in-depth knowledge of any of the other ones.
I've tried the others a bit, like Umbraco, and I've tried Orchard, and I must say Orchard is, out of them is the most usable for me, but it boils down to the person, I would say. But for me, it was also the most usable and most friendly one that gets the job done.
I'm glad to hear that, because usually one of the critique of Orchard is that it's not really well usable. So the UX, especially for non-technical people, is not that good.
Well, maybe that for technical people, it's maybe the best thing.
Yes, because quite on the contrary, for technical people, it's quite usable, and you also get a good framework as a developer.
And to tinker with all the things. I think my sound is dropping.
Yeah, so basically Orchard is good if you are looking for something as a foundation to build your own web application on top of it, especially if you are building a multi-tenant platform, like when you are a media agency and you want to bulk host a lot of client websites which are technically similar, and you can do that very efficiently with Orchard. But if you are looking for a package that has basically everything built in and is super user-friendly, but you are not looking into extending it that much, then Orchard is not the best choice.
Yeah. But I must say, I mean, it's still based on ASP.NET. So if you really need to hack something together, you can. It's not like you're limited to the framework itself. You can, as a developer, you can go deeper and customize it however you want it.
Yeah.
That's absolutely right.
You can do that with .NET Nuke as well, I think. I think these are the CMSs that developers like to use. Just change it to whatever you like. Let's go through some news first for what happened last week.
The news.
What was going on last week, and let's change my screen a bit.
Last week is already
update. Do you all have it?
Well, now
I have.
I just updated it.
Maybe you can do the demo again, Fanie, with a little bird.
I'm actually just looking at getting the picture to you, sent to you. They can put it on the screen. it's not really going to work on the glaring, and my battery is running out, so it's going to be not working. I will.
Demo.
It's a funny demo. I'm going to quickly send this to you. I can just find it. But carry on.
Yeah, well, one of the things in the Fall Creators update is it was just announced last week, I think, or the week before that, where they announced to introduce this Windows mixed reality environment in Windows 10 in the new version, where you get some sort of a home where you can stick all your applications to the wall and look at it with your mixed reality headsets. And they announced the new Samsung headset at the time. And that's also the one that's not available today, but I believe next month. November 6th is what's stated here. I think this was what you did just now, Fanie, a couple of minutes ago before the show, like showing virtual shark on the screen.
Yes.
And actually, this is what was Apple was showing off with their phones a couple of weeks before. Yeah, so they are all in the same space a bit, because also Google did the same thing with the with their own devices.
I must say, Windows had split screen first.
Yeah, and let's be fair, Microsoft came with the HoloLens, but as usual, they often tend to be too soon with a lot of this stuff.
Yeah,
and they really have an interesting device showing some great applications with it. But it's still very expensive, $3,000 to $5,000, I believe.
Yeah, but I was looking at the headsets for
the mixed reality headsets.
Yeah, the lower end ones. Well, I call it lower end comparing to the HoloLens.
$300 to $400.
That's better, I would say.
Fair price.
You would need a PC, but still.
I hope to get one with Sinterklaas.
Do you know what Sinterklaas is, Zoltán?
Yeah, I think so. I have a bit of German education, so I can guess. Santa Claus.
And what do they have? You're from Hungary, yeah?
That's right.
So, do you have Santa Claus, or what do you have there over there? Or?
We have Santa Claus, but it's kind of just a very small deal, and it's on the 6th of December. Children get a bit of sweets, but that's it. The big event is
Sinterklaas in the Netherlands is also it's on 5 December, because his birthday is December 6th, and then he's going away already. But the celebration is on December 5th in the Netherlands. So I hope to get some mixed reality devices as a present from Sinterklaas.
So not for Christmas, but even before that?
Yeah, not for Christmas. It's early December, so yeah, December 5. And what we see is that we are getting closer to the traditions that the US bringing also. So I think at this time the Netherlands it's celebrating twice. So you have the Sinterklaas, the Dutch one, December the 5th, and at the end of December, Christmas, we tend to do a little bit of Santa Claus also. So we try to double our presents there. And my son is having his birthday the day before Christmas, so it's a month full of partying. Our house.
Maarten, I've sent you the email. If you can maybe bring it up. Of that bird. My laptop's dead. My good old Surface Book is dead. I guess I could get a Surface Book 2 for Sinterklaas. Please.
Yeah, that was the other news. Maybe I can switch to that. It's a nice bridge, Fanie.
I've read the show notes.
The Surface Book 2 was announced, I think at the same time as the RTM of Windows 10 Fall Creators Update. They came with the Service Book 2. It was quite a surprise. They had a secret press conference in New York to show off the new devices, and that was a week before launch. So they were pretty well with the keeping the lid on it. And it's a bit faster. There's a new processor in there, and also the graphics processor is a bit more higher end. And also the pricing, I guess, is a bit higher, and it's still not available in the Netherlands. A bit later, also, I think. You know,
It's a myth. No, I have no idea. But like, I've ordered mine from I've actually ordered mine late, my Surface Book 1, and I've ordered it from the UK.
Yeah, not that long ago, I think, that you ordered it.
I think it's a year ago, or just a year and a bit.
Wow. Let's open the picture that Fanie sent. Let's see.
So just excuse my wife's messy office.
It's your own. There's a pizza box on there.
Well, it's not a pizza box. It's a kind of a... Let me just leave it there. Look at the bird.
And did you create the bird yourself, or did...
No, I've
demo?
If you open the mixed reality application, the mixed reality viewer, that I can actually show if I have this update. Let me just see. Mixed reality. Yes. Mixed reality portal. Oh yeah, yeah. I can quickly show this.
Bird's actually carrying. It looks like an old Sony Walkman. It's underpants.
So I'm gonna quickly share my screen. Share. So do you see my screen?
Yeah.
Yeah.
So you can just go to the mixed reality cell, mixed reality viewer, and it will actually bring it up like this. Some welcome screen. So there's a little bird.
Yeah, that's a big bird.
That's a big bird now. This is how it started, and you can tilt it around.
This one has different trousers on.
It's the same one, isn't it?
No, this was his swimming trunks, and if you look at your picture,
this is weird.
Where it's
because I haven't changed anything. I just opened the app, and the nice thing is now if I do it mixed reality view, yes, hopefully, I will actually.
If you look at this one, let's switch my screen again. Look at this. He's in his underwear here.
So are we gonna
swimming trunks? No.
Switch to my screen again?
There's a little hand there, but
do you see my screen?
I see your screen, but you're still trying to put it somewhere.
No, I'm waiting for you to switch the screen, so it's actually showing on the.
Yeah, you're on screen.
Oh, that's funny because okay. In any case, so I'm holding my hand like this, and I should actually just I don't know. This thing is supposed to point where I can put it, but in any case.
Yeah, I see a little hand going up and down.
Yeah, let's just put it there.
It's now
as I move around, see this thing is now.
Yeah, on your chest.
Kind of on my chest. It's quite cool. There we go.
That's on your shoulder.
It's not a parrot, but it's a kind of a. You can actually do like I'm gonna do the show like this now. Further.
Yeah.
And then you can go further and do this whole remix 3D thing, which is a whole store of 3D things. So now let's add maybe.
Yes, I see.
Ooh, the spider.
Oh, that's cool. Let's put the spider on my
something.
Ooh. It would be cool if they actually move, you know?
It's not yet Halloween.
There we go. Spider. Let's put them here. This is quite cool. There we go.
It's quite interesting because they didn't say too much of this before the release.
Then I can go Paint 3D. It just opens up Paint 3D on the other screen. Then I think it will actually allow me to edit this guy.
And you are doing this with your standard
webcam? Paint 3D is a standard program, yes.
I mean, you are doing this with your standard webcam.
Yes.
When you are mixer.
Well, I've got a special Logitech Braille, which has depth sensing, but surely it has nothing to do with that, because I don't know.
How did we look at it? And because you somewhere.
My webcam is, because I'm sharing my screen. My webcam is off, so it can utilize my webcam for this
Oh, okay. You shared your screen with the. So you weren't really looking at your webcam.
No, yeah, I shared my screen and then the thing popped up. Yeah, so you can actually edit this thing further, and maybe let's draw. I don't know how this works. It's just, I don't know. I'm not an expert.
Click on it.
I don't know. There we go. Done. We've clicked something, and I wonder if you can actually save it, go back, and it will actually update the updated image. I doubt it.
I think you created a new one because you got another window with the ball in it.
Nice, Spidey. Oh, nice, Spidey. No, this is great. Any case.
Totally off topic, but
it's totally off topic, but that's how we roll, eh? Any case, let's rather go to the news, because we have an awesome demo by Zoltán later.
Yeah,
and we don't want to waste any more time.
Go quickly over the other ones. So we have the Surface Book 2, and we have a new old mouse. This is the old IntelliMouse.
I had one like 15 years ago.
Yeah, and I think I have it somewhere around here. But that's a very old one, and the wheel is very sturdy and not working so well. And but they created a new one, and it's a bit more smooth. And if you look at it some other angles, it's really looking like the old one, but it's a bit more modern, I think. So I probably will buy one to see how it's working, because I used to like this mouse a lot. With the Fall Creators update also came introduced the files on demand on your OneDrive came available. But what is happening is that this OneDrive files on demand feature is not released in one go. Apparently, people were complaining that they didn't get this when they got the Fall Creators update. So someone from Microsoft actually explained that this one is introduced in small segments. So not everyone will get this one at once. You can force it though. If you go over the article, there are some links in here explaining what you can do if you really want to have it now.
Is the files on demand that logo with the cloud and the checkbox?
Yes. So if you go to your Explorer, then you see this list of files, and depending on what is the status of your file, if it's in the cloud or on-prem, or there's a third state. I'm not sure what it is, but
locally something blah blah blah.
Yeah. But that's a really useful feature, I think, because you used to have, if you installed your new Windows version on your small 32 gigs little tablet, and then you connected to your OneDrive, you used to get a complete filled hard drive with all this crap on your OneDrive. But nowadays it's downloading initially nothing until you actually put on the activated folders that you would like to download on your system. So that's so if you don't get it, just go to the website and try. We put it in the links also, and you can force it to download on your machine. And there's announced the .NET Framework 4.7.1. It's I think a minor. If you go to the SAM versioning, it's a minor update. I think some smaller things with encryption and stuff. Well, go over it yourself. Read it.
You can put the show notes, details in the show notes.
I said we want to go over to the guest, and because he has some stuff to show us. CodeRush 17.1.9 also available. Then there was this week also an introducing Gluon.
What's that?
Have any one of you heard of this?
Gluon, a new library for machine learning.
For machine learning, but there's a joint venture between AWS and Microsoft. So they're doing this together.
They're doing a lot of joint ventures. Yeah. Like if you look at Alexa and Cortana.
Yeah, if you read the book by the book of Satya Nadella, then he's really explaining that his goal is to do a lot more just to improve the systems over competing systems. So he wants to be more open in what they are doing and sharing information, and because his view on thing is that you can build better companies just by joining things together with other people and making more joint efforts. And I think there's a point there. TechDays was last week. We were there for 2 days. We did shooting some footage there, and Fanie created this small impression video.
Yeah, impression video, yeah.
And that's also we put also in the links. We won't show it here.
It was funny because the official one that TechDays made last year, I've looked back on it and it had like something like 70 or odd views. Our one, we also did one last year about the impression. Roughly about the same time we did that, and I actually think we made ours first, but then ours has I think roughly 170 views.
Yeah, your count was higher than the official one.
Yes, which is quite funny.
The Gluon thing is also on GitHub. I just found the site is on GitHub as well, so you can look into that. Also in the show notes, .NET's versioning table, explaining where we are today, the .NET Standard 2.0, Core 2.0 framework. That's actually 4.7.1 should say, I think, over here. So it's already, I think this is from a couple of days ago, but it's already outdated. Mono, Xamarin, blah, blah, blah. Team Foundation Server 2018 and SQL Server available. Let's see what is the release candidate 1, and we're already now in the Orchard CMS that I just opened in the .NET. So that's the news for this week. There's obviously more news, but we want to keep it a bit shorter than we used to do. So back to our guest.
Yeah, let's talk now quickly about Hastlayer. That's why you're here, Zoltán.
Yeah. That's right.
I have absolutely no idea. I'm busy reading up on Hastlayer and what it does, but as a developer, I don't have any idea what FPGAs are. Maybe you can just start with that tone in mind. Just maybe explain to sort of me first what Hastlayer solves, and then maybe just go from there with your demo. Would be great.
Yeah, no worries. I'm prepared to do that. So we would start with something on the basics, and to give you a general understanding of what Hastlayer is, what kind of devices it uses, and spoiler alert, they will be FPGAs, and why this is useful for you to get to know. So if I can take over the screen, I would also start with a bit of PowerPoint. I know, shame, but
Sure.
I would do that. And that would,
yeah. Just a quick
that would also,
shot of this website. This is the website, eh? Hastlayer.com. This is your
that's
site.
right.
Yeah. So let's go ahead. Yeah. Oh, you have your screen also.
Oh, sorry, I didn't know that I've taken over your screen.
No, that's okay.
Yeah, so anyway, what I would like to show you now is how to turn your computer softwares into computer chips. And another spoiler alert, it will be about .NET. So not very surprisingly, it has to do with Microsoft or Microsoft technologies, but it's about .NET. Well, just a bit of introduction. We have already talked a bit on about Orchard, and that I'm coming from a company called Lombic Technologies is the full name. We are actually doing a lot of Orchard work, a lot of Orchard-based web application development. That's our day-to-day job. We actually work with exclusively foreign clients, mostly from Western Europe and North America, including the Smithsonian Institution or even Microsoft itself. We once trained a Microsoft team on how to develop with Orchard. So that was quite a funny setup. That Microsoft started to develop Orchard, then the community took over. Among others, we also got to be quite active in the Orchard community, and then we got to train the developers of Microsoft. So the circle is now closed. But when we are not doing any Orchard development or anything related to the web, then we are doing sometimes research projects like Hastlayer. And actually, the inspiration of Hastlayer comes from my university time. When I was a student, trying to finally become a software engineer or a computer engineer, we also had a course on logic hardware development. I'm not sure. Did you have something along those lines, the gate level chip design courses?
Oh, that's really.
No.
No?
No, not me.
Well, we had probably because the curriculum was named computer science and electrical engineering, so we got to soldering and stuff like that. Yeah, probably that's fine. And it was quite cumbersome. So to create logic hardware, it's a very different paradigm than writing software. You need to use very different tools. And coming from a software development background, it was very alien, very hard to grasp, and the tools very hard to use. But, well, we managed, but still it struck me that there should be a way to do this in C#. Well, at the time, there wasn't really a way to do that in C#, but now there is. So let's see. And before we go any further, just a word of warning. Hastlayer works, and it works pretty well, I think. But it's not really ready for prime time yet. It's not ready for production level workloads at this stage. We will be pretty soon, but you can play with it, evaluate it, but just don't expect to run it in a server cluster yet.
You know, all developers will go try to run it in a server cluster now.
Yeah, that's what I also do all the time. I see something new, then I quickly go to my private server cluster and oh no, don't do that at home, please. Well, what is Hastlayer? And I'm especially addressing this to all the attendees here who don't know what Hastlayer is, and obviously, why should you know what Hastlayer is? Well, it's a program that we have created that takes a computer program and turns it into a computer chip. So we could also say a piece of logic hardware. Now this, I hope, sounds quite interesting. But to dig a bit deeper, what actually Hastlayer does is that it takes some logic expressed in software form and tries to create some equivalent logic expressed as hardware. So what the results, the software and the hardware will compute should be the same, but they should have the same logic inherently, but one was software and the other will be logic hardware. And all of this happens with some cool devices called FPGAs. FPGAs, or field programmable gate arrays, are basically computer chips that can behave like any other computer chip. So once they are manufactured, they can be reconfigured to behave like another application-specific processor. So, for example, you could configure an FPGA to behave like a small CPU, or you could configure it to multiply matrices in the thousands. You can configure it to do anything as long as it's physically possible, and as long as it fits on the chip, because obviously it has some
the first time I heard about these FPGAs, what was I think in context of Azure, where they put this in their own servers to speed up the servers.
That's right.
So
that's actually on my slide.
They were able to double the speed of the servers by doing this.
I can't recall results, but you are absolutely right. FPGAs, among others, are now also in Azure data centers. They are not publicly available yet, but I think that all new Microsoft servers, the ones going into Azure DCs, but also the ones not going into public data centers, they all have FPGAs inside now. You can't just access them, well, yet at least, but they accelerate networking capabilities of the whole cloud fabric. But where you have probably also used them is when you search something on Bing, because Bing is also accelerated by FPGAs, partially. But FPGAs are actually also commonly found in some routers among the household items. Or if you went to a doctor and got an X-ray or a PET or a CT scan, then those machines also commonly have FPGAs. And self-driving vehicles, autonomous vehicles, sometimes also use FPGAs for certain computational tasks.
So how do things compare with the EPROMs? Is that comparable? Is it the EPROMs, the EPROM?
Yeah, not really. EPROMs are memory chips where
dumb, I think, because put in they're kind of dumb chips and put in just a program part. So what's the difference between these?
Well, although I'm not an expert on EPROMs, as far as I know, you can store data in them, and that's it. Okay. FPGAs are much more flexible than that. You can basically design a logic hardware and put that on them that will compute anything you want them to compute.
Okay, wait.
As mentioned, you can.
So for me to understand this now, so EEPROM that Maarten just said, I know those things. Well, I don't know. I know of those things, and you say that's more like for storing just normal data. FPGAs is more like for storing runnable programs.
Not exactly. FPGAs don't really run programs or not really store programs.
Okay.
But rather they basically mimic a piece of logic fabric.
Okay.
So with logic gates, with AND gates, XOR gates, and wires. That's what you can put on FPGAs.
Okay. Oh, you see. So your logical if will be a hardware if on FPGA, for instance.
Kind of like that.
Okay, I'm getting this.
This is not
slowly.
Yeah, so it's somewhat like software-based hardware.
It's a bit like that, yes. It's called reconfigurable hardware.
Yeah.
But it also allows you is that you can write codes and create hardware from it, and you can reconfigure your FPGA anytime. So it's similar to software in a way, indeed, that you write software, then you run it on a CPU or a GPU or whatever, and then you can change the software and run it again. With FPGAs, you can do the same thing with hardware.
Yeah, so basically you can just you have one device and you put some stuff in it and it's doing X, and you put some other stuff in and now it's a Y device.
Yes, so you can also
Switch
think
it
about.
from what it's doing.
Yes, pretty much. So you can also imagine this like you have a chip on your in your computer or in your CPU, and this is actually not the reality yet, but possibly it will be. You have a chip in your CPU or a piece in your CPU that can be an accelerator for video decompression. So if you watch movies in 8K or 16K, it will be smooth. Or when you start a game, it will behave like a chip that can accelerate the physics engine of that game. So it can be. It's basically an application-specific chip that you can create with FPGAs.
Okay.
And all that dynamically. But since it's a chip and it's hardware, you have to be a hardware engineer.
Exactly, and and now all the software guys are like, we don't know what you're talking about.
Yes, because it's completely different, and we haven't done that as software guys yet. But don't worry, because with Hastlayer we have a solution for that. And if you were thinking along the lines of Raspberry Pi or Arduino, NetDuino, those are something completely different. The FPGAs also have visible circuit boards, but they have nothing to do with microcomputers like the Raspberry, or with microcontrollers like the Arduino and NetDuino platforms. To give you a bit of a general idea, just with some totally non-scientific, very crude estimation, here's a bit of comparison between CPUs that we all have programmed and GPUs in video cards, which we probably haven't all programmed, and FPGAs that probably nobody on this call except me have used. Well, first of all, there is the question of parallelism, the degree of parallelism these devices can supply. Well, with CPUs, it's probably 4 or 8 cores in your desktop machine. Well, the Intel i9 now has more, but that's the general level of hardware-based parallelism that you have in your desktop computer. And while there are server CPUs with 32 and 64 cores, it's pretty much. Now with GPUs in orange, it's the opposite extreme. GPUs are very highly parallel devices with thousands of little processing cores, simple ones, but a lot of them. And FPGAs are kind of in between. Although FPGAs don't really have cores, so to say, although that's not always true, because FPGAs can have that level of parallelism that you configure them to have. And it depends on your algorithm and on the capabilities of the FPGA, but generally this is in the order of magnitude of hundreds, sometimes thousands with high-end FPGAs. Well, what about the complexity of programs you can write for these devices? Well, CPUs can run pretty much anything that you can write as software, so we are good there. On the other hand are GPUs again. Programs that run on GPUs are quite limited in what you can use there, what structures, what kind of programming paradigms. Well, this is the price you pay for parallelism. FPGAs are, again, kind of in the middle. Although you can't program FPGAs, but with high-level tools like Hastlayer, you can still create a program and somehow magically turn it into an FPGA implementation. And commonly, the limitations on that side are kind of in between, with Hastlayer as well. Now, power efficiency on the right-hand chart is where FPGAs really shine. CPUs and GPUs are roughly on the same level, although this depends on the application and the specific devices. But FPGAs are very power efficient. since they are application specific, so they do just what you want them to do and nothing else, they can do a lot of stuff in a single clock cycle and with a single watt. So if you are talking about performance per watt, then FPGAs can be very good there.
So can you mine Bitcoins with this?
I was just about to ask the same question.
Not anymore. With Bitcoins, there was a very short era, like a few months long, where FPGAs were competitive. But then the price of Bitcoin and the demand for Bitcoin was becoming so high that creating application-specific integrated circuits, so basically Bitcoin-specific chips, was economic.
Yeah,
and they started to create Bitcoin ASICs.
I ask because I only heard about it. I'm not an expert on this. Is that they use a lot of GPU stuff to do this, the Bitcoin mining, but they are very power inefficient. So as I noticed your sheet with the power efficiency of this one, I was thinking maybe Bitcoins is a good target for this. But it's as you say, it's not already not efficient enough anymore. So they build chips for it.
Yes, because ASICs are kind of ASICs are what you can do when you have hardware engineering knowledge, and you also have a few tens of millions of dollars to manufacture those chips that you design. Because when you are designing a chip, then obviously once it's manufactured, it's done. So you can't change that. You can't fix issues, and you have to have a level of scale to make that actually feasible. Yeah. And with Bitcoin, that was reached a long time ago. And since with Bitcoin, the power efficiency is kind of the key with Bitcoin mining, there it really matters that with ASICs you can get even better power efficiency than with FPGAs, and a lot better power efficiency than with GPUs. But there are other cryptocurrencies than Bitcoin, and with others, I particularly know about Dash and Zcash, probably Ether as well. They are using FPGAs for mining.
Okay, nice. The FPGA also, from a power perspective, is almost like the Tesla of the chips. Let me put it to you that way. Three times more efficient.
That's an interesting way to put it. Well, yeah, compared to CPUs and GPUs, it could be, yeah. But all of this comes with a price, obviously, since with great power efficiency comes great responsibility. The issue is that it's very hard to learn utilizing FPGAs. The programming CPUs is easy enough. Programming GPUs is a bit harder, but every software developer can do it eventually, on certain level at least. But utilizing FPGAs is really hard. It's hardware design, hence the name hardware design, because it's hard. It's a completely different paradigm. You have to know completely different tools, think in completely different terms. Because now you are not writing a program that runs on a CPU, but you are creating some wiring and gates and chip level ports and buffers. It's very different. But with high level tools like Hastlayer, we aim to get this down to the level of CPU programming, and I think we are almost there. So to get back to our train of thought, Hastlayer actually takes a computer program and turns it into FPGA logic. And as already mentioned, not just any computer program, but .NET programs. Since Hastlayer processes .NET Common Intermediate Language assemblies, or just intermediate language assemblies, actually anything that compiles to .NET can be used, at least in theory. So this includes not just C# and Visual Basic and Managed C++, but also functional languages like F#, or even scripting languages like Python, PHP, and JavaScript. And all of them can be turned into a piece of computer chip. But why are we doing this? Well, obviously because there are some advantages, particularly due to the degree of parallelism FPGAs offer. It can be much more efficient performance-wise to run something or to execute something on an FPGA if the algorithm is possible to be massively parallelized and is compute bound, so CPU bound. And at the same time, we can get a power efficiency increase as well. And with Hastlayer and similar high-level tools, it can be still software development. And now we will have a demo to see how it works.
Yay.
I'm now switching to Visual Studio. I hope this is not a shock to anybody watching this. What we see here, or what we have here, is a very simple parallel algorithm, as the class name also tells. And this is just standard C#, so nothing really special here. If you are a C# developer, you will understand everything. What this algorithm does is nothing really useful, but it's really a kind of an exaggeration of what kind of algorithms are especially suitable to be accelerated with FPGAs and does with Hastlayer. Well, it takes an input and as a number, an input number, and then starts tasks. So if you are not familiar with the task parallel library in .NET, it's basically an abstraction over threads. If we are starting tasks like here, then the .NET thread pool will decide how many threads will be used and when. And my i7 CPU in the desktop computer I have here has 8 logical cores. So the actual hardware level parallelism will be 8. So there will be roughly that many threads running in parallel. Well, actually more, but you get the idea. But we will actually create 280 tasks here. That means that on my CPU, we will still have 8 cores, 8 logical cores. But once this is turned into hardware with the FPGA that I also have wired up here and prepared, then there will be 280 independently working little processing cores on the FPGA. Okay. So we will get some actual hardware level parallelism.
Cool.
And obviously, this can be quite some performance advantage. We'll see. But back to the algorithm, what it does in the tasks, well, nothing really complicated. There is some conditional logic inside, which is run 10 million times, and then the result is turned back. Now, next, we await all of these tasks. And when they are all finished, we are summing their outputs, which will be the output of our whole algorithm. So I've also run this, and this is part of a small console application, and we will see how this actually performs. What happens now is that Hastlayer processes the assembly, creates an equivalent hardware description, and once that's done, it shouts out whether there's a compatible FPGA connected, and if yes, and that execution will actually happen 3 times. And it happened. And what we have here is that all 3 times it took around 300 milliseconds to complete this on an FPGA, and around 400 to also the communication round trip included. Because this FPGA here is a low-end, relatively cheap $300 US development board, and it's connected to my PC via USB port, via USB cable. And this.
So from my understanding, you actually have a hardware device connected here.
Yes. Unfortunately, I can't share my screen and show my webcam at the same time. But once I'm done here, I will be able to show you how it's blinking here. And
so that program, the console application now, is it connecting to the board, or is it running on the board?
It was running on the board. Well, not the whole console application, but that parallel algorithm class that I've shown you.
Okay.
Yeah, that specific task.
And how did it know to run on the board?
Sorry, how did it?
How did it know to run on the board? Because it obviously come up to the screen that it's running, but if you can just go to the code back quickly, I just want to see what's going on.
Is that's done by the Hastlayer?
Yeah, there's a bit of orchestration here.
Am I jumping the gun?
Sorry?
Oh, am I jumping the gun a bit?
Yeah.
Oh, sorry.
But
Okay, carry on. Sorry.
Now, since we are we are a bit short on time, I would have skipped that. But if you are interested, and this example is, by the way, on GitHub, so if you are missing something, you can still check it out later. There's a bit of orchestration needed, but it's basically this. We create a Hastlayer shell, then some configuration, and finally, here is the method call where we tell Hastlayer to create some hardware out of this assembly.
Okay, now I understand it. Okay, so it's like a proxy almost.
And there is a proxy actually here.
Yeah.
So if you correctly guessed that, this is basically the Hastlayer, the piece of Hastlayer API that will let you communicate with the FPGA. And as you can see, it's nothing really special because it's just method calls on the instance of your class, standard method calls. But Hastlayer will hijack those method calls and transfer them to the FPGA because you have to wrap your instances into a dynamic proxy.
So wait, if you have that output 1, output 2, and output 3 that calls into parallel algorithm.run, that will actually triggers the parallel algorithm class on the Hastlayer to execute that code for those numbers.
That's right. So these 3 method calls here will be hijacked by Hastlayer.
Yes.
And these will actually be executed on the FPGA.
Cool.
Yeah.
So this number here is transferred to the FPGA port. It does its computation and transfers the result back, but we just get it as standard .NET objects.
Yeah, that's cool.
Are they using? Okay, this is another stupid question. Are they using like machine learning with these kind of chips?
Not at the moment. So there is there wasn't really an application for machine learning here. It's an algorithmic transformation from the .NET logic to the hardware logic.
Okay.
And while we are here, here is also a standard CPU execution just to measure against. And if we go back to the results, we can see that it took 300 milliseconds on the hardware, but 400 if we also take the communication round trip into account.
10 times.
But
yeah,
yes, about an order of magnitude more on the CPU. Well, this wasn't a very precise measurement because I'm screen sharing, the CPU is doing a lot of other things, etc. But if you also take all of these out, it's still about 2 seconds on the CPU versus this low-end FPGA board.
about 5 times as fast.
Yeah, around that with the communication round trip. And although this is a low-end board, this kind of probably gives you an idea of what's possible. But we'll also support bigger, faster FPGAs to make this faster and to have some PCI Express connection, for example, that's obviously much faster than a virtual serial one.
Okay.
But let me also wrap up, unless you have any questions on the demo here.
I'm actually blown away. It's actually very nice.
I'm really happy. I'm glad to hear that. Let me just go back to the slide deck to wrap this up. Well, what do we have in the pipeline? Because as mentioned, Hastlayer is in an alpha stage, so we have to do something next. And for example, we have partnered with the Wigner Research Institute Wigner Research Center for Physics, which is part of the Hungarian Academy of Sciences here in Budapest. We want to see how we can further science with Hastlayer, whether there are suitable scientific computations that we can accelerate with Hastlayer. And it seems that there are a few good candidates. We are working on these. We are also looking into implementing a new number format called UNUM, which was invented by a mathematician called John Gustafson. The issue is that with Hastlayer, we don't have floating point support yet. So obviously, what you can do with Hastlayer in Hastlayer-compatible .NET code is limited. You can't just do anything, although the limitations are quite broad. However, for example, there is no floating point support. There are no double, no float. UNUMs are promised to be even better than these number types. So we are looking into implementing that in a Hastlayer-compatible way. And as mentioned, we only have a low-end board here right now, but we want to make Hastlayer high-performance computing ready. So to support bigger FPGAs, so you can put some production real-world workloads on them, and it will still be fast. Well, if you liked it, and I really hope you did, you can check out the SDK on GitHub, and be ready because FPGAs are coming to public data centers, to eventually to home computers as well, because I think we are there with FPGAs where we were with GPUs at the beginning of the beginning of 2000. It's some of a curiosity right now. It's mostly used by specialists for special use cases, but it's gaining traction, and eventually every software developer will be able to use them. And we are closing in fast.
If you can give me a simple special use case you just mentioned, just what would you say the application will be like?
Yeah, as mentioned, the class of applications is where it's massively parallelizable and compute bound. For example, video processing and image processing is a prime example, because there you have a lot of pixels, and even if you don't work on all of the pixels in parallel due to the algorithmic and hardware limitations, there is still a massive amount of parallelization available. But scientific computations with some particle simulations where you have a lot of different objects in your simulation that you need to track, and you can parallelize that, that's also suitable.
Okay, clear.
I think if you go to the demo from the last build conference where they identified in this video all these objects to track, like the chainsaw and all these power tools that they like to track, I think that would be a target to use this for, to speed up all the monitoring of these objects by analyzing the video input. And it's fairly complex, and you have to do a lot of parallel tasks there, and that would speed up there. I think like with Fanie, the difficult thing is to think of good use cases to put it in. That will be the hardest thing, I think, with this. I think it's very impressive because it definitely shows you the improvement in speed and processing power. It's very cool.
No, that's very cool. And Zoltán, if people want to get hold of you, they can get hold of you the quickest how? With your email?
Yes, probably. So just shoot me an email. I would be happy to talk about anything Hastlayer related. If you want to know more about Hastlayer, check out hastlayer.com. You will be able to reach everything from there, including the SDK on GitHub.
Wow.
And by the way, since you also mentioned the Build conference, Mark Rusinovich also showcased something FPGA related there. If I remember correctly, the demonstration was about translating the whole English Wikipedia into some other language.
Yes.
Few seconds.
But they just joined all these things together in one click of time. they were able to process all this information at once. It's very, very impressive demo. Yeah.
That was also done with FPGAs. So actually, machine learning and artificial intelligence are also areas where FPGAs are already utilized and have a future.
Maarten, do you have a link of that build thing? Also, I'm very interested in looking at it later.
Not right now I was quite, surprised.
Oh, well. Zoltán, thank you very much.
I find it because it's, I think it was in the keynote.
Yes, somewhere there.
Last build.
What a great demo.
Yeah.
This was
I was looking at the Hastlayer site. Let's switch the screen again. I also
by the way,
noticed you're on World Tour. Oh yeah, let's show it again.
Yeah, I just wanted to show you the FPGA that I couldn't before.
Okay.
So this is the actual prototype.
The USB. What is this? How is it connected?
Yes. Yeah. It's the cable here. Just you couldn't see it probably. Yes, it's a simple USB cable.
So that whole thing is called the FPGA. What?
Actually, not. This we commonly call an FPGA board, and the FPGA chip itself is right in the middle. This little dark chip here is the FPGA.
And
everything.
What do you call the board?
FPGA board.
Okay.
Or FPGA development board.
So, if you want to buy this, is this information on your site somewhere?
It is. It's not. We don't make it. You can buy it from one of the FPGA vendors. It's explained there what kind of boards you have to purchase. But eventually we will have some better options as well.
I was looking at your site, and there's a menu item World Tour on there. We are in the current item for today, but there's an impressive list on there with this couple of months, some entries in November, December, a lot. Are you doing this by yourself on your own, or is this a group of people doing this?
The talks are all done by me. I'm the lead developer of Hastlayer, and I'm doing most of the talking.
Okay.
But it's not just me who is doing the development, of course. We have a great team at Lombik with some very talented people also working on Hastlayer.
Yeah, so if people want to see more in detail, then they can pick one of these other events and either go. Are you going over there, or is it live meetings combination?
These will be remote meetings.
Okay.
Well, unfortunately, I can't visit everywhere, but there will be some on-site ones as well. But I don't think any of those is listed yet. Those will come.
I think we should see if we can try to get you over for one of our next events. It's probably next year, and then you probably made some progress already there, and show us some more information about it. And let's see if we can. If you like to do
I would be very happy.
Yeah.
I've been checking out some prices of the FPGA boards. It's quite expensive, actually.
The baseboard or the what?
Does the board come with the chip?
Yeah. So this board I've shown you is $300, the whole thing.
Okay.
But this is one of the cheapest ones. Just to give you an idea, high-end FPGA boards are in the multiple thousands.
Yeah, 7,800. Yeah, I saw. Yeah. Wow. Sinterklaas.
It's a fairly complex board. If I notice it, there's all these number things on there also, like the LED stuff and.
Yeah, why this is special is because this is a development board. That means that it's used by FPGA engineers and by students to test stuff. So you can also make LEDs blinking, use the display, use the buttons and switches, stuff like that. We don't use any of those, but it's there. on those higher end boards that you have also seen, this is missing because nobody would want to have them. There's just a big fat FPGA and a lot of memory.
Yeah, and probably as with everything that it's, my guess is it's lowering in price every year.
Yeah, it's well, the capabilities of FPGAs are rapidly growing as well, and what you can get for the same money is also getting bigger. So a few $100 gives you a usable FPGA like we have here, or usable for this purpose. And eventually you will have this even much more common. So probably you have heard that Intel acquired the second largest FPGA manufacturer, Altera, 2 years ago.
Oh.
And Intel is now an FPGA manufacturer, so they are also betting on that.
That's cool.
Yeah, the more you get them, the cheaper they got, and the more purposes you see where they can apply them. That the things are getting cheaper over time. Yeah. Well, we are running out of time a bit, so let's close up with the show. We have the usual gadget of the month. I want to show this one. It's the fidget spinner again. And the reason I picked this is because my son wants to use it. So it's the first one that I picked up. Marcel picked it actually up on the TechDays. And so this week, the gadget of the week is the fidget spinner. And I'm getting crazy about these things because they're quite annoying if you're not doing this yourself, but someone around you. Well, that's it was a quite interesting story that you presented to us, and let's see if we can get a follow up on this later, maybe next year, and maybe even get you at the SDN event to show your board actually to the people of our conference group.
Yeah, we'll get you excuse to come to Amsterdam.
That would be great. Thanks.
Thank you very much, Zoltán. Appreciate it.
Well,
Okay.
thank you.
So next show will be probably next Thursday again. So we'll see you next Thursday then.